All right, we're going to talk about Monte Carlo methods this week. So the examples below we'll review one at a time in subsequent videos. Right now, just the general idea that a Monte Carlo method is one where we'll use random numbers to solve not so random problems. And that's the basic idea. Now, we don't actually have a supply of random numbers in Python or most programming languages. So we use what are called pseudo-random numbers. Pseudo-random numbers are numbers that are actually computed through a function, so they can't be random. But that function is chosen in a way that they act random. So when you measure distributions of the numbers, they're evenly distributed. Knowing one number doesn't seem to give you a lot of information about the next number in the sequence, and so on. And in Python, you can import the random class, and it gives you a variety of functions that you can use, such as random.random, which gives you random numbers between 0 and 1. Let's kind of move this like that, maybe. Actually, maybe like that. So random.random, each time you call it, different nuns. And then there's also like random.randint, say 1 and 2, which gives you from the low to the high inclusive. And you can look up the rest online. Finally, there's this function that you're going to want to know called seed. And you can set the seed. And if you do that, the sequence that you get will be the same each time. So 0.0523, 0.087. Now if I go back and set the seed again, notice we get the same exact ones after, same exact ones after that. So seed is very handy when you're debugging programs that include random number generation, because otherwise each time you run it, you're going to get different results. Okay, so anyway, the basic idea in Monte Carlo methods is to just do something a lot of times, okay? And then if you're trying to see the odds of something occurring, simulate it, count the number of times it succeeded. The odds should be about the ratio of your successful trials over your total trials. You want to see the odds of rolling a 5 on a single die, a 6-sided die. Obviously, the odds are 1 in 6, but you roll the die over and over again. Count the number of times you got a 5, divide it by the total rolls. That should equal your the odds. Now, it shouldn't equal the odds. That tilde there is important. It should approximately equal the odds, with the law of large numbers kicking in, which is to say, as our total trials increase, we approach the expected odds. After all, if I roll a die one time, I only have 2 possible outcomes. I'm either going to get the 5 or not get the 5. If I get the 5, that's 1 out of 1, and I'm going to say 100% of the time you get 5s, which is ridiculous. If I don't get the 5, that's 0. And I'll say 0% of the time you get 5, which is equally ridiculous. So you can't trust the result of one roll, because you're guaranteed to get a fairly wildly incorrect answer. But if you have 100 rolls, or 100,000 rolls, or 100 million rolls, you start getting more and more accurate. And that gives us this time accuracy trade-off. For Monte Carlo methods, you can be more accurate. It only costs you more time. And one of the arts of using Monte Carlo methods is to get to be sensitive to this trade-off and choose a number of trials that gives you sufficient accuracy without taking excessive time. You can do a Google search on Monte Carlo methods, and you will find a whole bunch of stuff about it out there. Wikipedia, MathWorld, certainly good places to start. And if you were to look through Wikipedia, you will notice a lot of what we talked about. And then applications. Applications in the physical sciences, engineering, comp bio, graphics, statistics, etc., etc., etc. It's heavily used in mathematics and certain kind of integration. If you have a very poorly behaved function, such that the traditional tools of calculus aren't going to be useful for integration, it turns out that Monte Carlo is one technique for still integrating those kinds of functions. Heavily used in simulation and optimization, and so on. So this is the tip of a very large iceberg. We are not attempting to teach you all of this, just to give you the earliest taste of what Monte Carlo methods are and the kinds of problems one might be able to solve with them. Have fun.